Bismillahirrahmanirrahim. I welcome all the viewers in the fourth part of Lecture 5, and I hope all the previous parts have been watched by you. Before going towards our lecture, if you have not subscribed this channel, please subscribe it and click on bell icon so that you can get the alerts of newly uploaded videos. So let's move towards our lecture. In previous parts of lecture, we have covered decimal numbers, binary numbers, and octal numbers. We have also seen how a decimal number can be converted to binary number and octal number. In today's video, we will cover our last outline, which is hexadecimal number. Hexadecimal number is also called base 16 because it uses 16 digits from 0 to 15, and these are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For 10 we will use A, for 11 B, for 12 C, for 13 D, for 14 E, and for 15 we will use F. Hexadecimal numbers can be represented as a combination of number from 0 to 15 enclosed within the brackets with base 16. In this way, we can represent a hexadecimal number. Now we will convert a decimal number to hexadecimal number. For that we have a following decimal number. We have learned in previous lectures, while converting a decimal number to binary number, we divide that number by 2 because binary number has 2 digits. And while converting a decimal number to octal number, we divide that number by 8 because octal number has 8 digits. In this example, we are going to convert a decimal number to hexadecimal number, and hexadecimal number has 16 digits. Therefore, we will divide this number by 16. Dividing 75 by 16, we get 16 for the 64, 11 remaining. So writing 11 at the right side. Now we can see that we cannot divide this further by 16. Therefore, this process is completed here. The next step is to write these numbers in this direction. So after writing, we get 4B. In this chart, we can see that instead of 11, we can write B. So here we have written 4B with base 16. Let's take another example. Dividing 2954 by 16, we get 16 ones are 16, 13 remaining. So it becomes 135. 16 8s are 128. 7 remaining, so 7 will be attached with 4 and it will make 74. 16 multiplied by 4 makes 64. So 10 remaining. Dividing 184 by 16 again. 16 ones are 16. 2 remaining. After attaching 2 with 4, it will become 24. So 16 ones are 16. 8 remaining. So writing 8 at the right side. Now we can see that 11 can't be divided further by 16. So therefore this process has been ended here. The next step is to write these numbers in this direction. So after writing, we get B, 8, A. Here we can see that instead of 11 we can write B, and instead of A we can write A. So B8A is a hexadecimal number. Now we will convert a hexadecimal number to decimal number system. We have a following hexadecimal number. Now we will convert this hexadecimal number to decimal number, and for that each digit of the number will be multiplied by 16. So 16 multiplied by 11, 16 multiplied by 4. The second step is to put power on 16 starting from 0. So 16 raised to the power 0, 16 raised to the power 1. The third and the final step is to add both these values together. 11 multiplied by 1. We know that any number whose power is 0 will be equal to 1. So 11 multiplied by 1 plus 16 multiplied by 4. After calculating these numbers, 64 plus 11, and the answer is 75, and putting 10 in its base. Let's take another example. The first step is to multiply each of the digit with 16. So 16 multiplied by 10, because we can write 10 in place of A. 16 multiplied by 8, and 16 multiplied by 11. The second step is to put power on 16 starting from 0, 16 raised to the power 0, 16 raised to the power 1 and 16 raised to the power 2. The third and the final step is to add all these values together. 10 multiplied by 1, 8 multiplied by 16, 11 multiplied by 16 multiplied by 16, because 16 square means 16 will be multiplied by itself 2 times. After calculating these numbers, we get 2816 plus 128 plus 10, and the answer is 2954 and 10 in its base. I hope that now you will be able to convert any decimal number to hexadecimal number and any hexadecimal number to decimal number. So here this topic has been completed. Let's see its summary. So far we have studied 4 number systems, and these are decimal, binary, octal and hexadecimal. In decimal number we have seen that it has base 10 because it uses 10 digits from 0 to 9, and these are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And in this way we can represent a decimal number, a number enclosed within a bracket with base 10. On the other hand, binary is base 2 numbers because it uses 2 digits 0 and 1, and in this way we can represent a binary number. Octal number is base 8 because it uses 8 digits from 0 to 7, and these are 0, 1, 2, 3, 4, 5, 6 and 7, and in this way we can represent an octal number. The last outline which we have studied is hexadecimal. It is base 16 numbers because it uses 16 digits from 0 to 15, and these are 0 to 9 and A, B, C, D, E and F, and in this way we can represent a hexadecimal number. Thanks for listening. If you have any question regarding this video or regarding this topic, you can freely comment on this video. I will come with the new topic in my next video. Till then, Allah Hafiz. Stay home, stay safe.